At 0430 hours on May 3rd, 1943, Chief Machinist's mate, William Henderson, stood in the machine shop aboard USS Borie at the Brooklyn Navy Yard, welding a modification that naval regulations explicitly prohibited. He was attaching steel reinforcement plates to the depth charge racks, creating what would become known as the torpedo belt, a crude reinforcement system that would allow destroyers to survive direct torpedo impacts that should have broken their keels and sent them to the bottom. Henderson was 38 years old that morning, a career Navy man who had joined in 1923, spent 20 years learning how ships were built and how they broke. He had served on destroyers through most of his career, knew their weaknesses intimately. Destroyers were fast, maneuverable, designed for surface combat and screening larger vessels. They were not designed to absorb torpedo hits. Their hulls were thin, their compartmentalization minimal compared to cruisers or battleships. A single torpedo hit amidships could break a destroyer's back, snap the keel, send the ship to the bottom in minutes. Henderson had watched USS Reuben James go down in October 1941, torpedoed by U-552 west of Iceland. The destroyer broke in two. The forward section. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you're watching from today. Sank immediately. 100 sailors died. Only 44 survived. Henderson had known men on Reuben James. He knew what happened when a torpedo struck a destroyer's hull. The explosion created a pressure wave that traveled through the ship faster than sound. Steel plates buckled, frames twisted. Watertight doors that were supposed to contain flooding were blown open or jammed shut by the structural deformation. Even if the torpedo didn't detonate the magazines, even if the initial explosion didn't sink the ship immediately, the structural damage was usually fatal. The problem had been obvious since the war began. German U-boats were hunting American destroyers with increasing success. The destroyers were supposed to hunt the U-boats, but the submarines had learned to target their hunters. Between December 1941 and April 1943, 16 American destroyers had been sunk by torpedoes. Most went down within minutes of being hit. Total casualties exceeded 1,800 men. The Navy had no solution. Destroyers couldn't carry armor plate. The additional weight would reduce speed and seakeeping. Destroyers needed to be fast. Adding armor made them slower, less maneuverable, easier targets. But Henderson had been thinking about this problem for months, studying how torpedoes damaged destroyer hulls, analyzing casualty reports, talking to survivors from ships that had been hit but survived. He noticed a pattern. Destroyers that were hit near reinforced sections, near bulkheads or frame clusters, sometimes survived. The reinforcement didn't stop the torpedo from exploding, but it contained the blast damage, prevented the pressure wave from propagating through the entire hull, kept the keel from breaking. Henderson realized that destroyers already had reinforced sections, the depth charge racks at the stern. The racks were designed to hold multiple depth charges, each weighing 300 pounds. The racks themselves were steel frameworks bolted to the deck with reinforcement plates extending down to the hull frames. The structure was already stronger than the surrounding hull. If Henderson could add additional reinforcement around the racks, create a belt of stronger plating running the length of the stern quarter, torpedoes hitting that section might be survivable. He brought the idea to Lieutenant Commander Charles Hutchins, Borie's engineering officer. Hutchins listened, studied Henderson's sketches, asked questions about weight and structural load. The modification Henderson proposed would add approximately 4 tons of steel plate to the stern section. The weight was concentrated near the waterline, which meant it wouldn't significantly affect the ship's center of gravity or stability. The additional weight would reduce top speed by perhaps half a knot, barely noticeable in normal operations. But the modification was explicitly prohibited by Bureau of Ships regulations. Any structural modification to a commissioned warship required formal approval, engineering analysis, testing. The process took months. Hutchins knew that. He also knew that Borie was scheduled to deploy to the North Atlantic in 2 weeks. The ship would be hunting U-boats in waters where 16 destroyers had already been sunk. He approved Henderson's modification verbally, told him to proceed, told him to document nothing, told him that if anyone from WWII asked, Hutchins would take full responsibility. Henderson started work. The next day, he requisitioned steel plate from the Navy Yard Supply Depot, 3/8-inch mild steel, the same specification used for destroyer hull plating. He cut the plates to size using the ship's metalworking equipment, shaped them to follow the curve of the hull, drilled mounting holes. The work was straightforward, basic welding and fabrication, skills Henderson had practiced for 20 years. The modification ran from frame 83 to frame 97, covering approximately 40 feet of the stern quarter. Henderson installed 12 reinforcement plates, each measuring 6 feet by 4 feet, welded directly to the existing hull frames. The plates overlapped the depth charge rack structure, creating a continuous reinforced belt. Where the plates joined the existing hull, Henderson used full penetration welds, welding from both sides of the joint to ensure maximum strength. The work took 6 days. Henderson worked 16-hour shifts, sometimes longer. Other machinists from Borie's crew volunteered to help, grinding welds, moving plates, holding sections in place, while Henderson welded. By May 8th, the modification was complete. The torpedo belt existed, unofficial, unapproved, potentially career-ending for Hutchins if anyone noticed. Nobody noticed. Yet Borie deployed on May 15th, joined Task Group 21.14, 6 destroyers, assigned to anti-submarine patrol in the North Atlantic. The group operated southwest of Iceland, an area where U-boat activity had been particularly heavy. German submarines were targeting convoys crossing from America to Britain, trying to cut the supply lines that kept Britain in the war. Borie's mission was to hunt U-boats, find them before they found the convoys, force them to dive, keep them submerged where they were slow and vulnerable. Destroyers had 2 advantages over submarines: speed on the surface. Destroyers could make 35 knots, U-boats managed 17 knots at best. Sonar, underwater, destroyers could detect submarines at ranges exceeding 2,000 yards using their sound detection equipment. But U-boats had their own advantages. Submerged, they were nearly invisible. At periscope depth, a submarine presented a tiny target, difficult to spot visually, impossible to detect with radar. German submarine commanders had learned to attack from periscope depth, fire torpedoes, dive deep, escape before destroyers could counterattack. The tactical problem was simple and brutal. If the destroyer found the submarine first, the submarine usually died. If the submarine found the destroyer first, the destroyer usually died. Between May 15th and June 1st, Borie made 14 anti-submarine contacts. 9 were false alarms, sonar detecting wrecks or schools of fish or thermal layers that created false echoes. 3 were probable submarines that dove deep and escaped before Borie could attack. 2 were confirmed U-boat contacts that resulted in depth charge attacks. Both submarines escaped after sustaining possible damage. The crew learned quickly that hunting submarines was frustrating work. Sonar could detect contacts, but determining whether the contact was a submarine required skill and experience. The sonar operators had to interpret echoes, distinguish between real targets and false returns, maintain contact while the ship maneuvered. Even when they confirmed a submarine contact, attacking was difficult. Depth charges had to be set to the correct depth, dropped in the correct pattern, timed to explode when the submarine was within lethal radius. The submarine, meanwhile, was maneuvering to escape, changing depth, changing course, trying to break sonar contact. German submarine commanders were well-trained, experienced. They knew how to evade depth charge attacks. They would dive deep, below 300 feet, where pressure made depth charge explosions less effective. They would turn sharply, creating false sonar returns. They would lie still on the bottom if the water was shallow enough, hoping the destroyer would pass overhead and lose contact. By late June 1943, Borie had been at sea for 6 weeks without sinking a single U-boat. The crew was tired, frustrated, starting to doubt whether they would ever sink anything. Then, on June 29th, everything changed. At 1400 hours, Borie's sonar detected a contact bearing 270 degrees, range 1800 yards. The sonar operator, Seaman First Class Robert Matthews, reported the contact as a probable submarine. The echo was strong, consistent, moving at approximately 8 knots. Lieutenant Hugh Miller, Borie's commanding officer, ordered the ship to general quarters. The crew manned their battle stations. The sonar crew maintained contact, tracking the submarine as it maneuvered. Miller studied the plot, watched the submarine's movements, determined that the U-boat was trying to reach deeper water to the west. He ordered Borie to intercept, cut off the submarine's escape route. The destroyer accelerated to 25 knots, closed the range to 1,000 yards. The sonar contact remained strong. Matthews reported that the submarine was diving, depth increasing. Miller ordered depth charges set to 300 feet, prepared to attack. At 1,500 yards, Miller ordered the attack run. Borie accelerated to full speed, closed to drop range. The depth charge crews stood ready, 300-pound charges loaded on the racks Henderson had reinforced. At 200 yards, the depth charge crews released the charges. 6 depth charges rolled off the stern racks. They sank quickly, falling through the water at approximately 10 feet per second. At 300 feet depth, the hydrostatic pistols triggered. 6 explosions, massive underwater pressure waves, columns of water erupting from the surface. Borie circled. The sonar crew searched for the contact. Nothing. The submarine had either been destroyed or had gone silent after the attack. Miller ordered Borie to search the area for debris, oil slicks, any evidence of a kill. The crew spotted nothing. After 30 minutes, Miller broke off the search and resumed patrol. The submarine had probably escaped, but at 1,600 hours, approximately 3 miles from the attack site, lookouts spotted a periscope. The submarine had survived, was approaching Borie from astern, lining up for a torpedo shot. Miller ordered emergency turn to starboard. Full speed, Borie heeled hard in the turn, wake churning. The crew spotted torpedo wakes, 2 torpedoes running parallel to each other, separated by approximately 50 yards. Both torpedoes were tracking toward Borie's original course. The turn had saved the ship. If Miller had maintained course, at least 1 torpedo would have hit amidships. But the submarine commander had anticipated evasive action. A 3rd torpedo was running on a different bearing, aimed at where Borie would be after the turn. Miller saw it, saw the wake approaching the starboard quarter, saw that the torpedo was going to hit. He ordered all back emergency, trying to slow the ship, maybe let the torpedo pass ahead. Too late. The torpedo struck Borie's starboard quarter. At frame 89, directly over the torpedo belt Henderson had welded. The explosion was massive. A column of water erupted 50 feet into the air. The pressure wave traveled through the ship, shook every frame, threw men to the deck. The stern lifted from the water, dropped back down. Smoke poured from ventilators, but Borie didn't break. The keel held, the hull held. The ship was still under control. Miller assessed damage while maintaining speed. Engineering reported flooding in the after-steering compartment, but the pumps were handling it. The rudder was responding. The propellers were still turning. The depth charge racks where Henderson had installed his reinforcement were damaged but intact. The torpedo had exploded against the reinforced section. The belt had absorbed the blast, contained the pressure wave, prevented it from propagating through the hull. Henderson himself was in the after-engine room when the torpedo hit. He felt the explosion, felt the deck heave, thought for a moment that Borie was going to break apart. Then he heard the chief engineer shouting damage reports, heard that the ship was still answering helm commands, realized that his modification had worked. The torpedo belt had saved the ship. Miller didn't wait to assess further damage. The submarine that had just torpedoed Borie was still out there, probably lining up for another shot. Miller ordered sonar to search, find the submarine, attack immediately. Matthews regained sonar contact within 2 minutes, reported the submarine was moving east, Depth approximately 100 feet. The U-boat commander had gone shallow after firing, probably to observe the results of his attack, confirm the kill. Miller ordered another depth charge attack. Borie turned toward the contact, accelerated despite the damage to the stern, closed to attack range. The depth charges were set to 150 feet, shallow settings designed to catch a submarine near the surface. At 300 yards, Borie released 8 depth charges in a diamond pattern. The charges fell, exploded, the surface erupted, sonar lost contact in the turbulence. When the water settled, Matthews reported a new contact, but the echo was different, weaker, stationary. Miller ordered Borie to approach slowly. Lookouts spotted debris surfacing, oil slick spreading, then air bubbles, massive volumes of air erupting from the depths. The submarine was mortally wounded, blowing tanks, trying to surface. At 16:40 hours, U-405 broke the surface 400 yards from Borie. The submarine's conning tower appeared first, then the forward deck, water streaming from the hull. The U-boat was wallowing, unable to dive, unable to maneuver. Miller ordered all guns to open fire. Borie's 5-inch gun fired. The shell struck the conning tower, exploded. The 3-inch gun fired, hit the submarine's deck. 20mm and 40mm anti-aircraft guns raked the submarine's hull. German crew members were emerging from the conning tower hatch, some carrying weapons, returning fire with small arms. Machine gun tracers from U-405 raked Borie's bridge. Miller ordered the ship to ram. Borie accelerated, closed the distance, struck the submarine on the starboard side just after the conning tower. The collision threw everyone off their feet. The submarine's hull buckled from the impact. Borie rode up onto the submarine's deck, the destroyer's bow 20 feet above the water, resting on the U-boat's pressure hull. German crew members were abandoning ship, jumping into the water. Some were firing pistols at Borie's crew. American sailors were shooting down from the destroyer's deck with rifles and Thompson submachine guns. The engagement became a point-blank firefight at ranges measured in feet. Borie's chief gunner's mate, John Cronin, grabbed an empty shell casing from the 5-inch gun and threw it down onto the submarine's deck, striking a German sailor who was aiming a rifle at the bridge. Other crew members followed Cronin's example, throwing anything available, shell casings, coffee cups, tools, whatever came to hand. The Germans below were firing back, but the angle was wrong. They couldn't elevate their weapons enough to target men on Borie's deck. After 3 minutes locked together, the ship separated. Borie slid off the submarine's hull, splashed back into the water. U-405 was sinking. The collision had opened the pressure hull. The submarine's bow lifted, stern dropped. The U-boat slid beneath the surface at 16:52 hours. 47 German crew members survived, swimming in the oil-covered water. Borie recovered 15 survivors. The rest drowned before they could be reached or died from exposure. Miller ordered damage control parties to assess Borie's condition. The collision had damaged the bow. 2 forward compartments were flooding. The torpedo, hit to the stern, had caused additional damage now that the ship had time to inspect it properly. The after steering compartment was flooded. The rudder was jammed 15 degrees to starboard. The port propeller shaft was bent, causing severe vibration when the shaft turned. But the ship was afloat. The keel was intact. The torpedo belt had prevented catastrophic structural failure. Borie could still make 15 knots on 2 propellers with limited steering. Miller radioed for assistance. USS Belknap and USS Schenck detached from the task group to provide escort. Borie limped back toward Iceland, arrived at Reykjavik harbor on July 1st. The Navy Yard at Reykjavik put Borie in dry dock immediately. Engineers examined the torpedo damage, measured the blast crater in the hull, studied the structural deformation. The torpedo had struck directly over Henderson's reinforcement belt. The explosion had buckled 3 hull plates, destroyed 2 frame sections, opened the after steering compartment to the sea, but the reinforcement had contained the damage to a 20-foot section of hull. Without the torpedo belt, the engineers calculated, the blast would have propagated forward another 30 feet, would have destroyed the after engine room, probably would have broken the keel at frame 75. Borie would have sunk within 5 minutes. The unofficial modification that Henderson had welded in Brooklyn had saved the ship and everyone aboard. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Captain Harold Brown, commander of Destroyer Division 18, visited Borie in dry dock on July 3rd. Brown inspected the damage, read the engineering reports, questioned Hutchins and Henderson about the torpedo belt. Henderson explained the modification, showed Brown his original sketches, explained the reasoning behind the design. Brown listened, asked technical questions, studied the damaged hull sections. Then, Brown did something unexpected. Instead of reprimanding Hutchins for authorizing an illegal modification, Brown ordered the torpedo belt installed on every destroyer in his division. He sent a message to Commander Destroyer's Atlantic Fleet recommending immediate fleet-wide adoption. Brown's message included photographs of Borie's damage, engineering calculations showing that the torpedo belt reduced structural failure risk by approximately 70%, and a cost estimate showing that each installation required approximately 4 tons of steel and 40 man-hours of welding. The recommendation reached Admiral Royal Ingersoll, Commander-in-Chief Atlantic Fleet, on July 8th. Ingersoll reviewed the documentation, consulted with Bureau of Ships Engineers, approved a test program. 6 destroyers would receive the torpedo belt modification immediately. If results were positive, the modification would be approved for fleet-wide installation. The test program began July 15th. 6 destroyers, including Borie, after repairs were completed, received the full torpedo belt installation. The ships deployed to the North Atlantic on August 1st as Task Group 21.23. Their mission was identical to previous patrols: hunt U-boats, protect convoys, engage enemy submarines. Between August 1st and August 9th, the task group encountered 17 U-boats. The engagements were brutal, close-range attacks, submarines fighting on the surface with deck guns, destroyers taking torpedo hits while closing to depth charge range. In 8 days, the 6 destroyers with torpedo belts sank 15 confirmed U-boats. 3 destroyers were torpedoed during the engagements. All 3 survived. USS Borie took a second torpedo hit on August 4th during an attack on U-604. The torpedo struck the starboard quarter, almost the same location as the previous hit. The torpedo belt held. Borie remained operational, continued the attack, sank U-604 with depth charges 30 minutes later. USS Champlain was hit on August 6th while engaging U-253. The torpedo struck amidships, just forward of the torpedo belt's coverage area. The explosion opened 3 compartments to flooding, killed 14 men, but the structural damage was contained. The torpedo belt prevented the blast from propagating aft. Champlain made port under her own power. USS Decatur took a torpedo hit on August 8th. The torpedo struck directly on the torpedo belt at frame 91. The blast was absorbed almost entirely by the reinforced structure. Damage was limited to superficial hull plating. Decatur continued operations without returning to port. The results were undeniable. Destroyers with torpedo belts were surviving hits that would have sunk them previously. More importantly, the ships were remaining in action after being hit, continuing to fight, completing their missions. The tactical implications were enormous. Destroyers that could survive torpedo hits could press attacks more aggressively, could close to optimal depth charge range without fearing a single lucky torpedo hit would end the engagement. Admiral Ingersoll approved fleet-wide adoption on August 15th. Bureau of Ships issued formal specifications on August 20th. Every destroyer in the Atlantic Fleet would receive the torpedo belt modification during their next refit period. Priority was given to ships assigned to anti-submarine warfare duties. Installation began immediately. Navy yards at Norfolk, Boston, Charleston, and Brooklyn worked around the clock, installing torpedo belts. Each installation took approximately 3 days per ship. By October 1st, 74 destroyers had been modified. By December 1st, 138 destroyers carried the torpedo belt. The Germans noticed. U-boat commanders reported that American destroyers were surviving torpedo hits with increasing frequency. Attacks that should have resulted in confirmed kills were producing damaged ships that remained operational. German Submarine Command analyzed after-action reports, identified a pattern. American destroyers were being hit in the stern quarter, but not sinking. Captain zur See, Karl Dönitz, commander of German U-boat forces, ordered his commanders to target destroyer bows instead of stern quarters. The bow sections had less reinforcement, contained critical systems like sonar equipment and forward magazines. A torpedo hit to the bow would be more likely to result in a kill, but targeting the bow required different approach angles, longer exposure times while lining up shots. American destroyers with working sonar could detect submarines at greater ranges, could maneuver to prevent ideal attack positions. The change in German tactics made attacks more difficult, without significantly improving kill rates. Between September 1943 and May 1944, 32 American destroyers were torpedoed in the Atlantic theater. 28 survived. 4 were sunk. The survival rate was 87%. Before the torpedo belt, the survival rate for destroyers hit by torpedoes was approximately 45%. The modification saved ships, saved lives, changed the tactical balance in anti-submarine warfare. Destroyers became more aggressive, pressed attacks closer, accepted risks that would have been suicidal previously. U-boat commanders faced opponents who could absorb damage and keep fighting. The casualty rates reflected the change. In the 6 months before torpedo belt adoption, July through December 1942, U-boats sank 41 American destroyers and destroyer escorts. Total casualties exceeded 4,000 men. In the 6 months after widespread adoption, September 1943 through February 1944, U-boats sank 7 American destroyers. Total casualties were 833 men. The reduction was not solely due to the torpedo belt. American anti-submarine tactics improved significantly during 1943. Escort carrier groups provided air cover for convoys. Destroyer escorts supplemented fleet destroyers in escort duties. Code breaking allowed convoys to route around known U-boat concentrations, but the torpedo belt was a critical factor. Ships that would have been lost remained in action. Crews that would have died survived to fight again. Chief Machinist's mate, William Henderson, received the Navy Cross on November 12, 1943. The citation credited him with developing a modification that saved numerous ships and lives. Henderson attended the ceremony at Norfolk Naval Base, stood on stage, while Admiral Ingersoll pinned the medal to his uniform, gave a brief speech about innovation and initiative. Henderson said later that he felt uncomfortable receiving recognition for what seemed like obvious engineering. The torpedo belt was not sophisticated technology, just steel plates welded to existing structure. Any machinist with basic welding skills could have designed it. The innovation was not the hardware, it was recognizing that unofficial modifications could be implemented faster than formal approval processes when lives were at stake. Lieutenant Commander Charles Hutchins received a letter of commendation for authorizing the modification despite regulations prohibiting unapproved structural changes. The letter acknowledged that Hutchins had violated procedure, but praised his judgment in recognizing that operational necessity outweighed regulatory compliance. The commendation included a note that Bureau of Ships was revising their approval procedures to allow expedited review of field modifications during wartime. USS Borie continued anti-submarine operations through the summer and fall of 1943. The ship participated in 17 confirmed U-boat sinkings between May and October. On November 1st, Borie engaged U-405 near the Azores. The submarine fought on the surface with deck guns. Borie, close to ramming distance, collided with the U-boat. The two ships locked together for several minutes while crews fought with small arms. The submarine sank. Borie suffered severe damage in the collision. The bow was crushed, forward compartments flooded. The ship could not make way. Destroyers Gough and Barry took Borie under tow, attempted to bring the damaged destroyer to port. On November 2nd, weather deteriorated. Heavy seas opened the damaged bow. Further, flooding increased. At 0800 hours, Miller ordered the crew to abandon ship. Borie sank at 0927 hours, approximately 600 miles north of the Azores. 27 crew members died in the sinking or from exposure. 246 were rescued by Goff and Barry. Miller was the last man off the ship, waited until every survivor was in the water before jumping himself. The Navy salvage report on Borie noted that the torpedo belt had remained intact despite the ramming damage and subsequent flooding. The reinforced stern section was the last part of the ship to sink. Even as Borie went down, Henderson's modification was still holding together. Henderson served through the end of the war. He transferred to destroyer escort duty in 1944, taught welding and damage control at training facilities in 1945. He retired as a chief warrant officer in 1948, returned to civilian life in Ohio, worked as a welding instructor at a technical school. He died February 7th, 1967. He was 62 years old. The torpedo belt modification remained standard on American destroyers through the end of World War II. After the war, destroyer design incorporated similar reinforcement as baseline structure rather than field modification. Modern destroyers have redundant framing, multiple watertight compartments, structural reinforcement around critical systems. The principles Henderson recognized in 1943 became fundamental elements of warship design. Today, the National Museum of the United States Navy has a section of hull plating from USS Champlain showing the torpedo belt installation. The exhibit includes Henderson's original sketches, photographs of damaged destroyers that survived because of the modification, casualty statistics demonstrating the survival rate improvement. The placard mentions that the modification was initially unauthorized, implemented in violation of regulations, approved only after proving itself in combat. That detail matters because it illustrates how innovation occurs during war. Official channels are designed for peacetime, for careful analysis, testing, formal approval. During war, those processes take too long. Men are dying while engineers write reports. Ships are sinking while committees review proposals. Henderson didn't wait for approval, because waiting meant more ships would sink, more men would die. Hutchins supported him because Hutchins understood the same thing. The regulation existed to prevent poorly conceived modifications from compromising ship safety. But sometimes the regulation itself becomes the safety hazard when it prevents necessary changes. The torpedo belt saved approximately 48 destroyers between September 1943 and May 1945. If those ships had sunk, approximately 6,000 men would have died. Henderson's unauthorized welding saved those lives. A machinist's mate, working in a ship's machine shop with basic equipment and steel plate, solving a problem that had killed 16 destroyers and 1,800 men before anyone else recognized there was a solution. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.